All right, so away we go. So this is obviously a new setup here. We're in a new venue, namely my house. So the way this is set up is like this. So you guys need to go. If you can't see for some reason or whatever, or something's going on, let me know. Because if you don't tell me, I'm going to continue to do what I'm doing, and you still won't be able to see me. Okay. All right. So we're going to move on to 1.2, measuring and constructing segments. Measuring and constructing segments. Okay. What was a segment? We talked about what was a segment before, right? Segment is nothing more than a line, but a part of a line, right? So if we have A and B, the line segment was represented like that. The line segment was that. Okay. The very first postulate in the middle of page 13, postulate 1-2-1, states that the points on a line can be put into a one-to-one correspondence with the real numbers. All that really means is that you can go ahead and draw a number line on any line segment, okay? And that's all that really means, okay? So let's go ahead and jump into the example. Example number 1. Okay, before we talk about that, we have to talk about two distances, right? So this is if you have here, you have a line, and you have a line segment that is S and T, and the corresponding line number, or so this would be, let's say this was 5, and this was 7. The distance between the 2 points, or the distance or the length of the line segment, can be represented as B minus A with these 2 straight lines on the end, on each side. Can anybody tell me what those 2 straight lines are? What does that mean? Anybody?
Absolute value.
It's the absolute value, meaning what? If I have the absolute value of minus 5, what is the answer here? Anybody?
5.
5, right? So the absolute value, you basically are taking away the sign, okay? It's really the magnitude of the number, okay? So in other words, -7 is the same as this, which is 7, okay? The absolute value. The absolute value means that you will disregard the sign, whether it's plus or minus, and they all become plus. Okay. So the distance is given in this. Go ahead.
Kayla told me that she's waiting to be let in.
Oh, okay. Good job. Thank you. All right. So again, the distance is, you use this formula, B minus A, the absolute value. Well, actually, when you think about it, the absolute value of B minus A, the absolute value of B minus A is actually the same as the absolute value of A minus B. Okay, because you can swap them around, which will actually change the plus or the negative. But in the end, since you're using absolute value, they're all the same. So let's go and verify this. So if A was 5 and B was 7, the first one would be what? 7 minus 5. The second one will be what? 5 minus 7. So 7 minus 5 is 2. So the absolute value of 2 is 2. 5 minus 7 is -2. So the absolute value of -2 is 2. So yes, indeed, this thing works. Okay? All right. Okay, let's do example number 1. Example number 1, find the length of a segment. Find each length. And this is obviously, this is in the bottom part of Page 13, DC. So the length of DC, where the value of D is 4.5 and the C is 2. So this is example number 1. DC is going to be equal to 4.5 minus 2. We had a fourth value of 4.5 and 2. So it's going to be the absolute value of 2.5, which is just 2.5. EF. F was what? F was -1. Then E was -4, so minus -4. Absolute value. For absolute value, so negative, negative here, what does that become? That becomes positive, correct? So this is the same as -1 plus 4, which is 3, which is 3. Now you could have also said this is the same as -4 if I switch these around, right? Negative, -1 as such. Again, the negative becomes positive. So I'm going to end up with -4 plus 1, which is the same as -3, which is 3. Okay, so it works both ways. Okay, so flip the page. Copying example number. So talking about construction here, how to make or draw a congruent segment. Okay, if you look in there, there's that little doohickey there, or device, which is called the compass. Okay, the compass is something where you have 2 points, you have 2 little pins, really, and you set it, and once it's set, it does not move. In other words, the distance between point A and B stays the same. So you would open it up, and then you would go ahead, and once you set your compass, it stays the same. So no matter where you take that thing, it goes from here to here to here to here. They would all be the same distance, okay? The same distance in the segment, okay? Okay. So example number 2, how to copy a segment. You can go ahead and read that through. Okay. So step 1, estimate in sketch. Estimate the length of MN and sketch PQ approximately the same length. Okay, all right. You can use a ruler to measure MN, and if you do that, it appears to be 3.1. Use a ruler to draw X and Y to have the same length. In other words, if you don't have a compass, you can go ahead and use the ruler too. You can use a ruler to make sure that the segment lengths are the same. Okay. There's a postulate on the bottom of page 14. Postulate 1-2-2. Segment addition postulate. Okay, well, that says is that is that if you have a line segment that looks like this, A, B, and C, the segment length AC is the same as AB plus BC. That's all that means, okay? So you can add, if you add this plus this, albeit it's going to be the same as that, okay? That's what it means. Let's use this to do example number 3. Example number 3. B is between A and C, just like we have it here. So this is example number 2. We can use this same drawing to do example number 2. B is between A and C, where AC is 14 and BC is 11.4. So from here So I have AC is 14 from here to here is 14. I'm also given that BC is 11.4. So from here to here is 11.4. Find AB. So we want to find this length here. So this length here, AB, is going to be 14 minus 11.4, right? 2.6. Okay, so 2.6 is your answer. B. Okay, this is a little more complicated. S is between R and T. S is between R and T. So on this one, we have R, T, and then we have an S guy here. All right, S is between R and T, but we were given that, oh, here we go. So we were given that 2x plus 7. This guy here is 2x plus 7. And then we have from here to here is 4x. And then we have here to here is 28. And find the distance of RT. So we're trying to find this distance here, from here to here, the full distance, okay? So, and if we, so in order to know this, since we know this is 4x, we have to solve for x. Okay, we have to solve for x. But the relationship that we know here is that this guy plus this guy equals the whole length. So this guy, 2x plus 7 plus the 28 is equal to the entire length, which is 4x. Okay? So, what do we have here? Can anybody help me solve this? Jackson, unmute yourself. Walk me through this.
First you add the 28 and 7 together.
7 and the 28 together, you get 35, okay?
Okay. Then I would divide the 35 by the 2, so I get
Was there something you want to
17.5.
do before that?
Oh, you put the 4 over the 2, so it's 2x.
Okay, so you would have to move, you want to move the 2x over to the side, correct? You want to,
Yeah.
you want to combine the like terms, you want to combine them together, right? So if you move this guy over here, and over here, you're only going to have the 35. You had 4x. When you move this over, it becomes negative 2x, correct?
Mm-hmm.
Okay, so what's next?
That then on the right it would be 2x because it's 4x minus. Then you divide by the 2 and it's 17.5.
Now I divide by the 2, correct? 17 and a half, okay? 17 and a half. So is this my final answer?
No.
Why not? I thought.
Because you still have the 4.
Because they asked me what RT was, right? And RT is not X, but it is 4X, right? So I have to multiply this guy by 4. So RT, my final answer is 4X, which is equal to 4 times, 17.5. If I do that, I get 70. So that's my final answer. My final answer is this guy. RT is equal to 70 inches. Okay. Let's see. Eliora, unmute yourself. Are you there?
Yeah.
Okay. How would I verify or check that this is the correct answer? Is there a way to do that?
You could, yeah, you can add, or no, you can substitute what x was. So you can do 2, which is 2 times 17.5 plus 7.
Yes.
And
good job. So you're going to try to put that in here, correct? That's what we're doing here. So we're
Yeah.
what she's saying is that we're going to put the x over into here. So if I do that, I get 35 plus 7, which ends up being 42, right? And now I can add the 42 and the 28 and actually verify that my answer is 70. Okay? Good job. So that's how you would verify if you actually do have the correct answer here, okay? Okay. Oftentimes when you're taking a test and you are making a mistake and you recheck, and if you continue to solve the problem the same way, you're often going to repeat that mistake that you're doing. So this kind of recheck also gives you a different way to verify that you're doing, that your answer is correct. Okay? All right. Okay, let's do example number 4. The map shows the route for a race. You are 365 meters from drink station R and 2 kilometers from drink station S. The first aid station is located at the midpoint between the 2 drink stations. How far are you from the first aid station? Okay. A little complicated, but we can figure this out. Okay, so we have, I am here and there's a drink station R. There's a drink station S, and then between here, there is the first aid station. So I am here, from here to here is 365 meters. From here to here is how many? Is what? 2 kilometers. Can anybody tell me how many meters there are in 1 kilometer?
1,000.
Huh?
1,000.
1,000, correct. So 2 kilometers would be 2,000 meters, correct? 2,000 meters? 2,000 meters. And the first aid station is located at the midpoint. So in between these two, so this distance and this distance are the same here. Okay. So the distance between these two are going to be what? 2,000 minus 365, which is that. And it's in between that, in between that. So if I divide that by 2, I'm going to get what? 817.5. So in other words, from here to here is 817.5. And the question was what? How far are you from the first aid station? So you are from here to here. So you're going to have to add that 365 together. 2, 8. So that would be your final answer, 1182.5. Okay. Any questions there? That was actually that was a little easier than the other one before. All right, flip the page. And we have one more, using midpoints to find lengths. Okay, using midpoints to find lengths. So let's see if we can do this. Example number 5. Example number 5, we have B is the midpoint of AC. So we have AC, AC, and B is the midpoint. In other words, this and this are the same. AB is 5x, BC is 3x plus 4. So this here is 5x. This here is 3x plus 4. Find AB, BC, and AC. Okay, so I have to find this length, and the entire length. Okay. So the equation I'm going to use here, or the relationship I'm going to use here, is that this guy is the same as this guy. So 5x, I'll do it over here. 5x is equal to 3x plus 4. Let's pick on, who should we pick on? Let's pick on McKenna. McKenna, unmute yourself. How would I solve for x?
You would write 5x equals 3x plus 4.
Yeah,
And then you would subtract the 3x and minus it from the 5x.
okay. So I'm going to move this over. So I have 5x minus 3x. And now I only have 4 here. And then if I subtract it, McKenna is saying this is 2x. Okay. Now what?
Then you divide the 2x by 2 and do the same to the 4.
And I would get x equals 2, correct?
Yeah.
Good job, good job. So let's verify that works. So if I put x here, 5 times 2 is going to be equal to 10. If I put the 2 in here, I get 3 times 2 plus 4. 3 times 2 is 6, plus 4 is 10. So this is 10 also, right? So it works. But this is not our final answer. Our final answer is AB is equal to 10. BC is equal to 10, which means that AC is going to be equal to 20, right? So that should be your final answer. All right. So is there anything, we're done with section 1.2. Were there any questions on this, all we did so far? All right. If not, I'm going to go ahead and let you work on your homework.